In this second video in the PLCopen camming series, I'm going to show you how to add an instance of the MC-CAMTableSelect function block into a PLC program and how to set all the options for the inputs, including the cyclic input, the master absolute, and slave absolute options. I'm starting with a new ladder diagram program, which I'm going to add function blocks in order to implement camming into a program. The camming function blocks are located in our function block library under the Motion PLCopen Profiles section. Before I can implement an MC-CAMIN, I have to first call a CAMTableSelect function block. So I'm going to drag and drop that from the function block library into my ladder editor first. And I'm going to use just the default instance name, which you can change to be more specific if you'd like. And it will automatically add a new instance of this function block into your dictionary. Now, this function block you only have to call once in a project unless you want to change the different periodic, master, and slave absolute options for your CAM profile. So I'm going to add a contact and use an already created variable that's in our template program called bMotionEngineStarted. So this function block will be called once automatically when the motion engine or EtherCAT motion network first starts in my program. Now for the CAM table, if I go to the help file or just hover over the function block instance, it'll show me it's looking for a type string. So this is where you enter the name of the CAM table you want to use. So if I click back on the Project Explorer, I just kept the default profile name in the previous video, so I can enter that directly. Now if I double click right here, normally if I type profile and hit enter, it will have me create a new variable of type string, but I don't want to do that because I want to enter the string directly profile. In order to do this, you can enter the string you want around single quotes. If I do that, I'm entering the string profile directly and not creating a variable called profile. That trips a lot of new users up. The last three inputs are all Boolean inputs that choose different options that you can use with this CAM profile. The first is periodic. This means do you want the CAM profile to repeat or not? In this case I do, so I'm going to enter true. That means once the master gets to the end of its specified period, in this case after it moves 720 degrees, the CAM will automatically repeat and the slave will continue to do this same motion over and over again. If you do periodic false, that means if the master gets outside of the original window specified in the CAM profile, the slave will not move at all unless the master goes back into the specified window of the CAM profile. Master and slave absolute are similar, but I'm going to tackle them one by one. If you do false, then you do not use that option, meaning it will be master relative or slave relative. I'm going to do slave relative and master relative. So what does that mean? If I go back to my CAM profile for a little bit of visual help, first master absolute. If you do false, meaning you have a relative master CAM, then you will always start at the leftmost point of the CAM. When I eventually call CAM in, no matter where the master is, so the master could be at 400, the slave will always think that it's actually at 0, and you'll always start at this point in the CAM profile, meaning it would start going in a positive direction, then go back down to the constant velocity before going back up. If you had that option as true, meaning you had master absolute, then you could potentially start anywhere in the middle of this CAM profile. When you called CAM in, you would look where the master axis is at that specific point in time, and that will determine where you start in the CAM profile. For instance, if when you called CAM in, if the master is at point 200, then you would start at this point in the CAM profile. And instead of going positive direction first, the slave would go in the negative direction. Similar, you can also choose slave absolute or slave false. This is you got to be more careful with the option, because if you do slave absolute, you have the potential of the slave axis jumping and getting which can cause a lot of faults at the drive level, either over torque or over speed. So what I usually recommend is people start out with slave absolute set false, meaning do slave relative. That means when you call mccam in, it doesn't matter where the absolute position of the slave axis is at that point. The cam profile will execute in a relative fashion, meaning you'll still do the shape of the cam profile, but it won't necessarily, when the cam first starts, force the axis to go to -5 and then go all the way up to 3, back down to -2, and then back up to +5. What will happen is, it depends on where the slave axis actually starts, and then as the master goes through the period specified in the cam profile, the slave will move a total of 10 user units, but it won't necessarily always be between -5 and 5. Now, if you have slave absolute set to true, then if you're using this cam profile, the slave would always be between -5 and 5. And for instance, if the master started at 0 and you called mccam in with slave absolute on, and the slave was actually at a position of 2, it would try to be forced to be -5 immediately. So you do recommend, if you are going to do the slave absolute option to true, which some people do need for the accuracy required in their application, that they first will call mccam start position. So this function block you can input, and it will not actually start a cam profile, but it'll output the position that the slave has to be in order to prevent a jump from occurring if you were to call cam in. Lastly, all outputs of function blocks are optional, but in this case we will need to tie a variable to the cam table ID output, and so I'm going to just use that exact same name, cam table ID. And our ladder editor is smart. It knows that it has to be an integer type variable, and I'm going to make this a global variable. And now this integer output is what you're going to tie into the mccam-in function block, which I will cover in the next video in the series. So that's all I'm going to do for this initial video, and in the next one we will go over how you can add an mccam-in function block to actually start the master-slave relationship.